Hello everyone, welcome back to my YouTube channel. Today we'll be starting a new chapter of Class 9 Maths 1, that is polynomials. So the concepts which are discussed in this chapter are very important. So this chapter is going to be very important. So let us start with the chapter. So before starting the chapter, we'll recall some concepts related to equation which you have studied in 8th class. So let us recall. Firstly, what is equation? So as the word says that equation, it means something equals. So mathematically, we can define equation as a statement that supports equality of two expressions which are connected by equal to sign. For example, you can see here 2x minus 4 is equal to 16. Now here you can see that there are two expressions here. One is the left hand side and one is the right hand side. And both the expressions are separated by equal to signs. That's why this whole thing is known as equation. Let us see the parts of equation. For example, this is my equation 3x plus 4 is equal to 16. So here the number which is with the variable. So here x is my variable. So the number which is with the variable, this is known as a coefficient. Then this plus or minus, these are nothing but my operators because they are performing some operations. Then 4. Now 4 is not with a variable. It is separately. So it is my constant is equal to 16. 16 also my constant because there is no variable there. And this 3x plus 4 is my expression number 1 and 16 is my expression number 2. And both the expressions are separated by equal to sign. That's why this whole is known as equation. This is my equation. So expression. Now expression is nothing but it is combined. It is a combination of various terms. So here 3x is my one term, 4 is my another term, and I have combined the term with adding them, right? So this whole becomes my expression with two terms. Then the 16 is an expression with one term. So in expression there are multiple terms, 1, 2, 3, and so on. Let us see the types of equation. First one is linear equation. So linear equation may have more than one variable. Highest power of variable is always 1. So the linear equation, linear means 1. So here the power of equation, power of variable should be always 1. For example, 9x plus 3 is equal to 12. So here x is my variable and the power is 1. 3m plus 5n is equal to 8. Now here there are two variables. For variable m, the power is 1. For n also it is 1. So the highest power is going to be 1 only. That's why it is a linear equation. Next one is a quadratic equation. In quadratic equation, it means the power should be 2. The highest power should be 2. So at least one of the variables should be raised to exponent 2. Second order equation. Okay. For example, 3p square minus 1 is equal to 0. So here p is my variable with highest power 2. If it is like this, 3p square plus 5p minus 1 equal to 0. So here you can see variable is p. In the first term it is p square, in the second term it is p. So we have to see only the highest power. Highest power is 2, then it will come in quadratic equation. Though it has a variable p with power 1, but the highest power is 2, so it will come under quadratic equation. Next is cubic equation. Cubic equation means the highest power should be 3. So at least one of the variables should be raised to exponent 3. It is known as a third order equation. For example, y cube minus 64 is equal to 0. In the same example, if I add 4p cube minus 3p square plus 5p minus 1 equal to 0. So here we have to see the highest power. So highest power of variable is 3. So this will come under cubic equation. Okay. Now, there are some general formulas of linear equation, quadratic equation, cubic equation. For linear equation, the general formula is ax plus b equal to 0. Okay. So here my b becomes the constant. My b becomes the constant. X is my variable, a is my coefficient. And the variable x should have the highest power 1. So this is a general equation of linear equation. For quadratic equations, general equation is ax square plus bx plus c, where c is my constant. Then ax square. So here my variable x should have the exponent 2. Should be raised to exponent 2. That is the highest power should be 2. Then it is a quadratic equation. And if the highest power is 3, ax square plus bx, ax cube plus bx square plus cx plus d. So here my d becomes the constant. So I hope you understood what we have recalled from our previous lower classes, what you have learned related to equation. Now our chapter is about polynomials. So we are going to study about polynomials. Now what is polynomial? Polynomial, there are two terms here. One is poly and another is nomial. So poly means many and nomial means terms. So polynomials is nothing but many terms. So definition says that expression which is composed of variables, constants, and exponents. What I have said, expressions, only expression, not equation. Expression which is composed of variables, constants, and exponents that are combined using mathematical operations, operations such as for addition, subtraction, like this. Okay. So such expression which are composed of variables, constant, exponents, and are combined using mathematical operations, there are known as polynomials. Okay. Now these polynomials can have many terms. That's why there is a polynomials. Nomial system and poly means many. So these expressions have many terms. That's why they are under category polynomials. So the difference is here, this is not an equation. In equation, there are two expressions and separated by equal to sign. But here we have only one expression. Okay, we have only one expression, which is composed of different variables, constant, exponents. And there are many terms in that expression. That's why it is known as polynomials. Okay, now let us discuss about degree and terms of polynomial. For example, here I have a polynomial. 4x cubed plus 2x square plus 3x plus 8. So it is a composition of variables, coefficients, and exponents. So all the three things you can see here, operations, positive addition operation here you can see. So here there are so many terms here you can see. This is a term 1. Term 1 is 4x cubed. Term 2, that is 2x square. Third term is 3x. And fourth term is 8. And these four terms are each separated by operation, that is addition operation. Now here we have to learn what are the terms. So these are our terms. Terms are nothing but this 4x cubed, 2x square. These are something which are separated by operations. These terms are separated by operations. So here there are four terms, 4x cubed, 2x square, 3x, and 8. So I hope you understood what are terms. Next is degree of polynomial. What is a degree of polynomial? So here you can see I have written that degree of polynomial is 3. Why I have written 3? So degree of polynomial is nothing but the highest power of the variable. You can see in the expression. Throughout the expression, which is the highest power of variable, that will be my degree of polynomial. So here I can see the variable x, here the power is 1, here power is 2, here power is 3. And out of these three powers, the highest power is 3. So I can write the degree is 3. Okay. Now, if I give an example, if my polynomial is 3y plus 5, this is my polynomial. Okay. What is the degree of this? Degree is going to be 1 because the highest power of variable is 1. One more example, I feel. 22. This is a constant. 22 is a constant. It has no variables, it has nothing, no operations. It is only a single number, 22. So is this a polynomial? Yes. Why it is a polynomial? Because this is also a term. This is also a term. What will be the degree of this polynomial? So degree of this polynomial will be 0. How 0? Because I can write this 22 as 22 any variable raised to power 0. Now, if you know any variable raised to power 0 is nothing but equal to 1. Anything raised to 0 is equal to 1. If I say 2 raised to 0, 1. 5 raised to 0, 1. Y raised to 0, 1. X raised to 0, 1. So anything raised to 0 is always equal to 1. So if I replace y raised to 0 as 1, I can write 22 into 1, that is nothing but 22 only. So I can mention 22 as 22y raised to 0. Here also I can mention 4x cubed plus 2x square plus 3x plus 8x raised to 0. But we do not mention like this. We directly mention as a constant. So this is also a term with degree 0. Okay, I hope you understood the two terms, that is degree of polynomial and terms of polynomial. Let us discuss the types of polynomial. So there are different classification of polynomials. So this classification is based on number of terms that an expression has. This classification can be divided as only one term, two terms, three terms. So these are the basic classification or basic types of polynomial. Okay, we can divide it as like this also 4 terms, 5 terms, 6 terms. But we usually write only the first 3 terms classification. So if an expression has more than 4 terms, we directly call it as polynomials. What we call polynomials. If it has more than 4 terms, the general name is polynomials, many terms. Okay, so here we are learning only the first 3 types. Rest all are called as polynomials. So if it has only one term, the expression has only one term, like 10x, 10, 5x, 4y, this is only one single term. We call it as a monomial. Mono means single, meal is term, so single term, monomial. If it has 2 terms, like 3x square plus 2, so your 3x square is a term number 1 and 2 is our term number 2. So there are 2 terms here. We call it as a binomial. Bino means 2 and meal means terms. So 2 terms. Expression with 2 terms is known as binomial. Then if it has 3 terms, m raised to 4 plus m cube plus 4. So you can see the operator is separated by 3 terms. So we call it as trinomial. As tri is nothing but 3, nomial is terms. So expression with 3 terms is known as trinomial. So I hope you understood the basic classification of polynomials based on number of terms. Next, representation of polynomials. This is very important. Representation. How do we represent a polynomial? So polynomial is represented as p of x. P of x represents the variable used. So this x represents the variable. P stands for polynomial. So this is a polynomial. And x stands for which variable is used in that polynomial. For example, p of m. So here the whole equation, in the whole expression, the variable m is used. M square m. P of y. So here in the whole expression, the variable y is used. Like this. So the representation of polynomial is like this. P for polynomial, and in bracket we write the variable which is used in the expression. Next, types of polynomial based on degree. So we have learned about term and degree. So we classify polynomials based on term and degree. First thing, we have classified polynomial on basis of number of terms. Now we'll classify based on the degree. Okay, if it is a degree 1 polynomial, we call it as a linear polynomial. Similar to the equation, if the highest power in the equation is 1, we call it as a linear equation. Similarly, if the highest power in the expression is 1, we call it as a linear polynomial. If the highest power is 2, we call it as a quadratic polynomial. And if the highest power is 3, we call it as a cubic polynomial. So these classifications and all these things are related to types of equation. That's why first I recalled you the types of equation which are previously learned in lower classes. Now, let us see the general equation. General equation of linear polynomial. Ax plus b. We only need one variable with degree 1. That's why it's one variable. A is our coefficient. Ax plus b is our constant. But a should not be equal to 0. If a is equal to 0, so 0 into x will be equal to 0. So there will be no variable. And if there is no variable, there will be no power of 1. Right? So a is not equal to 0 here. Example 5x plus 2. So here the power of x is 1. which is the highest power. That's what is known as a degree 1 polynomial or linear polynomial. Next, quadratic polynomials. Here the general equation becomes ax square plus bx plus c. This is my expression. This is my expression. In equation, we used to equate it with 0. So here we are only talking with the expression because we are talking with of polynomials. So here a is also equal to 0 because if a becomes 0, then power of 2 will be also 0. If a is 0, then here bx plus c will become our linear polynomial. The next is cubic polynomial. So the general equation is ax cube plus bx square plus cx plus d. So here also if a is equal to 0, if this term becomes 0, then the polynomial becomes a degree 2 polynomial, right? So that's why the a should not be equal to 0. For example, 2x cube plus 4x square plus x plus 5. So in this expression, the highest power of variable is 3. The degree is 3 here, right? So this is a degree 3 polynomial, which is known as a cubic polynomial. So I hope you understood the types of polynomial based on number of terms as well as based on the degree of polynomial. Now we'll discuss about the forms of polynomial. So basically there are 3 forms of polynomial. One is standard form of polynomial, one is index form of polynomial, and another one is a coefficient form of polynomial. So let us understand the forms of polynomial in detail. First one is the standard form of polynomial. Okay. First one is the standard form. So writing polynomials in descending power of its variable. This is nothing but a standard form of polynomial. For example, you can see a polynomial here, y cube plus 8y raised to 4 minus 3y plus 4. So you can see in the first term, the power of variable is 3. In the second term, the power is 4. In the third term, the power is 1. In the fourth term, there is no power, right? So if you can see here, the variable, power of variables are not in a proper manner. If we arrange them in a descending power means highest to lowest. So the highest power you can see in the whole expression is 4. So I am writing the term with highest power first, 8y raised to 4. Then after 4, 3. So term with power 3. Then term with power 1. If there is no term with power 2, then we no term with power 2. So if not 2, then 1. So 3y plus 4. So like this. So in descending order of powers, if you write the expression, then that expression is in the form of standard form of polynomials. Next is index form. What is index form? Writing the polynomial including all missing powers. All missing powers. Same example I am taking. Y cube plus 8y raised to 4 minus 3y plus 4. Okay. So here I am writing the polynomial in standard form as well as in index form. In standard form, you can write in descending order, ascending order in index form. But the important thing is that you should write the missing powers also. What do you mean by this missing powers? You can see in the question, power 3 is there, power 4 is there, power 1 is there, power 0 is also there, right? Missing is that fourth power is there, third power is a square, second power is missing. So I'm writing here 8y raised to 4 plus y cube. As the second power is missing, I'm writing it as 0y square. Why 0y square? Because there is no term with variable y square. But we have to show that term as you're writing the polynomial in index form. So you have to show that term. So I'm writing here 0y square. 0y square is nothing but 0 and multiplied by anything is 0 only. But to represent it, I am writing it as 0y square. Okay. Minus 3y plus 4 as it is. So the difference between standard form and index form is that in standard form, you will mention or you will write the polynomial, write the expression in descending power of variables. Here, if some power is missing, then no problem. Whichever powers are present, that powers you have to write in descending power. In index form, it is not like that. In index form, you can write in any way. The powers you can write in any way, but the missing power should be represented. Okay. Last one is coefficient form. Coefficient form. So in coefficient form, you have to write only the coefficient of variables. Coefficient of variables by considering all missing terms in standard form of polynomial. So in coefficient form, what you have to do? You have to, if suppose same question I'm taking. So this is my polynomial. First, you have to write that polynomial in standard form. After writing, you have to also write the missing terms as well, that too in standard form. Okay, so in coefficient form, it is important that all missing terms will be included. With that, the polynomial should be also there in standard form, that is descending power of variables. So this same thing I can write as 8y raised to 4 plus y cube plus 0y square minus 3y plus 4. So here all the powers you can see here, fourth power, third power, second power, first power and power 0. So all the 5 powers are there here. And then only I can write it in the form of coefficient. What is the coefficient? The number which is with the variable. So here I can see with y square, the number is 8. So my first coefficient will be 8. And comma, I have to separate the coefficient with commas. Then y cube. There is no digit with y cube. So it is nothing but if there is no digit, we assume it as a 1, right? We don't write 1 y cube. It is equal to y cube. The second coefficient is 1. Then for y square, the coefficient is 0. So comma 0. Then here minus 3y. Power of y is 1 here. Coefficient of y is here minus 3. You have to also look with the signs. So minus 3. And last, it is a constant. Constant, that is y raised to 0. This is also a coefficient, right? So it is a 4. So this is how we write the coefficient form. Okay, now there will be questions in the exam where you have to convert coefficient form into index form into standard form, or standard to index, standard to coefficient, and so on. So like this, there will be questions given in your exams. Okay, so let us discuss one example here to understand it. So this is our polynomial 6x minus 3x square plus 4x raised to 5 minus 2. So we have to write in all the forms. We have to write it in standard form, index form, and coefficient form. Okay, so first we write in the standard form. So what is the standard form of this polynomial? So while writing the standard form, you have to remember that the power should be in descending order. So here you have to see which is the highest power. So the highest power is 5. Then after 5, which is the highest? I can see here 2. So 3 and 4 are missing. Then after 2, it is 1. And then constant. So how are you going to write this? We are going to write it as 4x raised to 5 minus 3x square plus 6x minus 2. This is our standard form of polynomial. Next one is index form. What is important in index form? Order is not important. Important is that the missing term should be included. So here I can see that highest power is 5, lowest power is 0. So between 5 and 0, 5, fifth power is there, 4th power is missing, 3rd power is missing, power 2 is there, power 1 is there, power 0 is there, right? So here 2 powers are missing, that is 4th and 3rd. So here we will mention 0 x raised to 4 and 0 x raised to 3. So these two terms you have to mention. So my index form will be 4x raised to 5 plus 0x raised to 4 plus 0x raised to cube, and rest things same. Next one is coefficient form. So in coefficient form, what is important? You have to write the coefficients, that too with all missing terms, and that too with the standard form. So here we'll consider this index form here only, because this is this is in standard form as well as the missing terms are present. So I can write the coefficient as first highest coefficient is 4, then 0, then 0, then minus 3, then plus 6, and then minus 2. Right? So this is my coefficients. So coefficient form I can write 4, 0, 0, minus 3, 6, minus 2. So I hope you understood what we have learned today. So we have learned all the concepts which are required for solving practice set 3.1. This is the end of today's session. I hope you understood all the concepts and you found this video helpful and interesting. So do like, share and subscribe our channel for more such videos. Thank you.